last session of our two-day event. This evening, we will be listening to Professor Dr. Henry Lai with the moderation of Aydın Akan. We will be discussing the effect of electromagnetic fields on flora and fauna in general life. Let me introduce you Aydın Akan. In 1988, he was graduated from Uludağ University, Electronic Engineering. In 1991, Istanbul Technical University, Electronic and Communication Program, Master's degree. In 1996, Pittsburgh University, Electrical Engineering, PhD. Between 1996 and 2017, he had been an academic in Istanbul University, Department of Electrical and Electronic Engineering. He became a professor in 2006. In 20th of March 2017, he became professor in Biomedical Engineering Department of Katip Çelebi University. Between May 2017 and 18, he acted as the Dean of the Department of Engineering until 31st of January 2021. He was the head of the department and the center and director, as well as being the BAP coordinator. In 1st of February 2020, he became professor in İzmir Ekonomi University, Electricity and Electronic Engineering. Professor Dr. Aydın Akan is expert on time frequency analysis for non-stable continuities, and he works on their application in biomedical engineering. Yes, please.
Sağ olun Asuman Hanım. Herkese iyi akşamlar diliyorum.
Henry, can you hear me at the moment? The interpreter is speaking. Henry Lai, if you are hearing me, please give me a sign. Apparently you are not listening to me, that's why I am not interpreting, translator.
1971 yılında McGill Üniversitesi'nden fizyoloji BS derecesini, 1977 yılında University of Washington'dan psikoloji doktora derecesini almış. Daha sonra 1978-80 yılları arasında yine University of Washington'da farmakoloji bölümünde postdoktora yapmıştır. Uzun yıllar Washington Üniversitesi'nde araştırmalarını sürdüren Profesör Lai, aynı üniversitede emeritus profesör olarak çalışmaya devam etmektedir. Electromagnetic Biology and Medicine dergisinin baş editörü olarak görev yapmaktadır. Elektromanyetik alanların biyolojik etkileri konusunda çok sayıda bilimsel eseri bulunmaktadır. Aynı zamanda uluslararası toplantılarda sıkça davet edilen bir konuşmacıdır. En çarpıcı çalışmaları kablosuz iletişimde kullanılan radyo frekans radyasyonunun sıçan beyinlerinde DNA hasarı oluşturduğuna ilişkin bulguları içeren araştırmalarıdır. Elektromanyetik kirlilik ve çevre üzerinde çalışmalarını yoğunlaştıran akşam bize elektromanyetik alanların yaşam, yani flora ve fauna üzerine etkileri konusunu ele alacak ve öneriler getirecektir. Professor Lai, the floor is yours. Thank you for joining us tonight. Please share your screen and you may start.
Okay. Thank you very much, Professor Akan, for the introduction. Thank the committee for inviting me to give the talk here. Turkey probably is the country that produces the most amount of bioelectromagnetic research now. There are many papers published, and there are many good researchers, bioelectromagnetic researchers in Turkey. So let me start my talk. So my the title of my talk is on the non-ionizing electromagnetic field and wildlife. Wildlife means the animals and plants that live on Earth. And
we cannot see your screen.
Okay, not see me. Okay, how do I do that?
The share screen button down.
Okay. Okay. It's quite interesting. How do I get the video back? Slideshow. Huh. I don't know how to get it back.
Is the presentation open?
Yeah, the presentation is open. Well, you don't have to look at me actually. Let's just go ahead because you don't need to look at me at all. Living organisms evolve over millions of years in the presence of static and extremely low frequency electromagnetic field, which is natural to the Earth. And these fields plays very critical importance in how animals survive. For example, birds in migration require the Earth magnetic field, and sometimes they need to do food foraging, which is also dependent on the bird's detection of food, of electromagnetic, especially static magnetic field. Homing is another very important thing, is that how the animal go back to their home after they come out from the nest or whatever. And they use the inclination of the magnetic field, the Earth magnetic field, for to locate a home. And such that they are very sensitive to the ambient normal electromagnetic field. Now, in the last several decades, maybe 50, 40 years, there has been an increase in man-made radio frequency radiation for example, from telecommunications. And for the 50, 60 hertz EMF, electromagnetic fields from electric power consumption.
Professor Lai,
yes.
Can you try to share this? Is the presentation on?
Yeah, the presentation is
on your
on.
Desktop?
Yeah. How do you share?
When you hit the share screen button, you can choose your PowerPoint.
Okay.
And when you hit the share screen button, it will show you different pages. Select OK.
Is it back?
Okay, very good. The presentation mode now.
Oh, okay, all right.
You remember? Okay, that one.
Yeah, okay, we'll go back. All right.
Very good, thank you.
So we talk about this changes in the environment of that includes the man-made electromagnetic fields. They are both from radio frequency radiation and also from 50 and 60 hertz electric fields and magnetic field. People generally talk about magnetic field, but it turns out that electric fields also play a very important part in an animal's survival. So all this new communication and power line system basically can disturb the normal function of animals. And the consequences can be very serious because that can disrupt migration or disrupt homing or disrupt the reproduction capability or behavior. And another thing is that over the years, this type of man-made field become higher and higher. Let's look at the measurements of radio frequency, radiation levels in the environment. There are many studies made in different countries, for example, in Australia, European country involving Turkey. Turkey actually has a very old record of recording radio frequency radiation. Dr. Ferrara in Ankara published a paper almost 20 years ago on radio frequency radiation levels in Turkey. And there are also studies on African countries, India, Korea, even in the Middle East, and USA. There's a very large variation in levels, can range from 0.002 to 41 microwatt per square centimeter. And the median level is 0.18 microwatt per square centimeter. These are old data, and I bet there are, if you look at the newer data, these levels are much, much higher than we have listed here. See a second. Now, there are also similar measurement of EMF magnetic field in the environment in different countries. And the range is from 0.45 to 16 microteslas. The median level is 0.77 microtesla, which is 7.7 millijoules. Now, so wildlife, if they live close to transmission towers or live to power lines, they are exposed to very high level of EMF. And studies on bioelectromagnetic study have shown that the effects can occur after exposure to level in the millitesla and milliwatt per square centimeter level. The SAR, which is the important measurement of absorption, RFR, radio frequency radiation absorption, greater than 4 watt per kilo, that this 4 watt per kilogram SAR is used in the setting of most of the recent radio frequency radiation exposure standards. Now, the question is, with low level, lower than 4 watt per kilogram, can have any effects on animals and plants. So we look at the literature and look for study less than 0.1 0.4 watt per kilogram. Now you have to notice that I have changed from the power density into the SAR, the absorption, because that is a more that is what we need to know is actually the SAR and not the power density. For a study that use less than 0.4 watt per kilogram, we found 103 studies, and some of these are in vivo study, 69% in vivo study, 34% in vitro study, which are cell studies. And the study are mostly less than 2.5 gigahertz. And also we included some, gigahertz millimeter wave data. The biological effects study in these 103 studies, there are many different types of studies. There are genetic study, oxidative stress, heat shock protein, cell proliferation, cell growth, blood-brain barrier, cognitive and memory functions, brain morphological changes, etc. So, and then 46% of these studies are acute exposure, that means one-time exposure, and 57 are chronic or repeated exposure, sometimes up to a couple of years of exposure. Now, when we look at all this data from the 103 paper, the SAR of this study, the medium SAR of this study are 0.0155 watt per kilogram, which is 15.5 milliwatt per square milliwatt per kilogram. And the mean SAR is 0.04 watt per kilogram. Now, it's better to use the median SAR as a guideline because all these studies are not normally distributed. So when you look at this and compare with the exposure level, wildlife can be exposed to a level of man-made radio frequency radiation in an environment that produces this SAR. For example, when you go up to the highest one is 40 microwatt per square centimeter. That's about 16, they can produce, or a standing man is about 16 milliwatt per square centimeter. So it's within the limit of what we found that can cause effect. And then we look at the static and extremely low frequency EMF. Have shown that the free radical formation can occur as low as 0.5 to 5 microtesla, which is quite low. And you can look up this paper, or you can write to me and I can send you a copy of this paper on low-level effect of ELF, static ELF on free radical. And genetic effects can also occur at 0.04 microtesla. And this is in the supplement 4 of this an article that we published recently. I will give you some information later about all these papers, and you can send us an email and ask for a copy for yourself. So the question is, man-made EMF, is it an environmental pollutant? is the pollution to our environment. Let's look at some studies on different types, species of animals. When we look at the rodents, which are the rats and mice and bats, and radio frequency and radiation and static electromagnetic ELF, EMF can affect fertility, reproduction, fetal development, neurological functions such as learning and memory, foraging behavior, and orientation. When you look at the cattle, bovine, radio frequency radiation have been shown to affect milk production, micronuclear formation in blood, these are white blood cells, melatonin production, cataract, etc. And ELF, EMF can also causes milk production effects, abnormal behavior, and blood thyroxine, which can occur 30 microtesla. Birds, birds have actually, EMF has a very large effect on birds because birds move around in the environment. They can be sometimes they can be very close to a transmission tower or a power line, and they're exposed to very high level of the fields. The effects include neural activity, morphological changes. Animal become more aggressive. Production of heat shock protein, which is indication of some protein damage in cells. Embryo development, growth and development of young birds, oxidative stress. There are many birds living close to a transmission tower. So this I talked about already. Another thing is insect and anaconds. This like beetles, ants, fruit fly, locusts, monarch butterflies, ticks in the wild. One of the interesting is the concern of this so-called colony collapse of bee colonies. The bees suddenly die, the whole colony just die for some unknown reason. There are many different other mechanism and explanation. And one of the explanation is that the electromagnetic field in the environment is causing this collapse. Because the bee contains magnetite, which is iron containing crystal, absorb EMF. And of course, this is very important because bees are so-called pollinators. They are very important in agriculture, in production of vegetables and things like that. And when 5G system using millimeter wave, there are resonance study on the resonance frequency. And it seems that some insects can absorb a lot of energy from the millimeter wave radiation. Another type of animal is amphibians. These are frogs and toads, and they have electroreception ability, also based on magnetites, and also the type of compound called cryptochromes. This critical cone involves free radical pair formation. This malatites and critical cones are involved in seasonal migration. Some animals, some of these amphibians can detect very low level of electric field. So we're talking about electroperception instead of magnetoperception. Thus, man-made EMF can possibly cause detrimental effects. And there are reports of radio frequency radiation causing deformation and a decline in population. And ELF, EMF have been shown to cause teratogenesis and microencephaly, delay metamorphosis, and maturation. Another thing is fish. In the water, they're more concerned on static EMF, particularly electric fields, and their emission from underground, undersea cables. There are reports of yolk sac absorption changes. These fish become less efficient in taking food, and they cannot gain weight as normal. There are also reports of disruption of sex steroid hormones. Some fish can show magnetic avoidance behavior at less than 20 microtesla. So they can detect this very low level of magnetic fields. Yeah, of course, study on nematode, which are worms, mollusca, protozoan, fungi, bacteria, and virus. Now, that's another thing which is very important and interesting is the effect of EMF on plants. Even maybe, well, in the early 20th century, there are proposal of using electromagnetic field to increase plant growth. For example, for rice or wheat, that food used for food consumption. Now, when we look at the effect of radio frequency radiation and ELF, EMF, for the biological effects of the different species of animal, they are usually have the same effect. So radio frequency radiation can produce one effect, and then when you look at the ELF, EMF, it can also produce the same effect. But this is not true in plants. It seems that there are many studies on different types of plants. And static and electromagnetic field enhances growth of plants, but RFR decreases growth. So it's opposite. So this is very puzzling. One of the possibilities that the cell wall of plants contains water molecules that can absorb radio frequency radiation and cause microthermal effects that decreases plant growth. And ELF, EMF cannot produce the same thermal effects. So what I talk about, you can find in more detail in this paper. I will give you some information on how to get a copy of it. So what are the mechanisms that of RFR and ELF EMF? There are many proposals. For example, cell membrane changes, ion channels. For example, there's a lot of debate on voltage-dependent calcium channels. Free radical involving radical pair and cryptochromes. Now, free radicals is one of the most well-established effects of electromagnetic field, non-ionizing electromagnetic field. There must be hundreds, several hundred studies that show effects. Stress response can be DNA damage or functional changes, can be resonances, can be can be detected by receptor cells, special receptor cells or organs. For example, platypus, they have a special organ that can detect electric current, and they can go down to detect 5 nanovolt per centimeter to 20 microvolt per centimeter of electric fields. These are equivalent to the contraction of a muscle of a shrimp. So that's how, in Australia, this platypus can dive down to a pond and they close their eyes and they just use the beak to detect muscle contraction of shrimps. And that's how they catch the food. And also, there are some studies showing that the birds can detect static magnetic fields. For example, when you pass electric static field over the bird, you can record cells firing at the occipital cortex, which is responsible for seeing. So there's some speculation that birds can actually see magnetic field. And of course, magnetize is another explanation of these effects. So I talk about these oxidative changes reported in hundreds of papers. And you can find this in papers, 2 papers that published Yakimento and myself. If you want an update, you can write to me at this address. I have the update up to last month on oxidative changes after exposure to EMF. There's wildlife affected by man-made fields and affect survival. There are several examples. For example, magnetic compass in songbirds are affected by 1.4 megahertz magnetic field at 2 to 3 nanotesla, which is again very, very low. And also the migration can be affected by 2 megahertz EMF in European robins. Also, this melatoperception has been reported to be affected in songbirds, European robins, and insect pollinator that we talked about at 1.2 megahertz, which is called the Lamar frequency. We have just published 3 big papers on effect of EMF on wildlife. And if you want a copy, you can write to Rick Levitt. And here is the email address. And you just ask her for a copy of the 3 wildlife paper that we published. The last one was published just a month ago. So she can send you a copy of this, of all these papers. But just use it for yourself and do not distribute because of a copyright concern. Okay. And actually, that's what I want to say, and I thank you very much for listening.
Thank you very much for this great presentation, Professor Lai. Let me see if we have any questions from the audience.
You got it?
Yeah. It seems I didn't get any questions, but I have one question for you. I think it is my extraction from your talk. It is not only the amount of electromagnetic exposure, I mean the level of electromagnetic field, but it is also the duration the wildlife is exposed, isn't it? I mean, the wildlife, they stay there for a long time.
Yeah.
I mean, we are concerned about the exposure to, I mean, cell phones and other sources, but we turn it on and off, but the creatures are always there. What do you say about that?
So your question is on the duration of
the exposure. Yes.
Yeah. I'm actually finished a paper on the duration of exposure. In general, the longer the duration of exposure, the higher the effect. But that's not always true. Sometimes you get the opposite effect. The longer the exposure, the less effect you get. So probably the animals and plants can compensate for changes. And so the thing is that radio frequency, radiation, and EMF magnetic field can be a stress to the animal. So what does stress do? Okay. And second, the animal can compensate, then you will not see any effect at all when you expose that. And the first thing that happens if the exposure continues, is the animal may die of the exposure, or some organ may just cease to function. So these are basically the stress response proposed by Hans Zeliat in the 1950s. So it's very difficult to answer your question, but in general, the longer the exposure, the worse the effect. But another thing that in our case is that we are exposed to different forms of the radiation. and the radiation is also modulated, right?
Yeah.
Most man-made fields are modulated, and particularly cell phones. And what does modulation do to the effect? We don't know. So the picture is it's much complicated than what we talk about here.
Yes, thank you very much.
Okay.
And the comment about the bee colonies, that was very interesting. In recent years, we have been hearing about that. And the electromagnetic exposure might be the reason for bee colonies disappearing, problems with bees.
Yeah. So
any additional comment on that?
It's hard to make any comments on what you want to say, but I'm glad that at this time, particularly the US, we don't get any funding to do research on EMF, and people in Turkey are doing a very good job. There are lots of papers published from Turkish researchers, and I'm really glad to see that.
Thank you very much. Thank you. And somebody from the audience write that how can they get the papers, and you explained in your talk that they can send you email.
Yeah,
and,
send an email or send an email to Brick. The last slide, Brick, BLAKE, Levitt, LEVIT at cs.com.
Yeah.
Yeah,
you can send the papers.
There are several hundred pages of paper.
Yes.
Together, so it's a good reading. So I would recommend it. Write to her at BLAKELEVIT at cs.com.
Okay, then. Okay, I got the name. And if there are no more questions, I will thank Professor Lai for this. Yes, I have one last question. Asking that, is it different for the living in the cities, whether human beings or animals, than wildlife? Are the effects different?
I would say in living in the city, you're exposed to a higher level.
Much more, yeah.
Man-made EMF.
There are many more sources there.
Yeah, because mostly, for example, in Turkey, they're mostly are from radio towers and TV towers transmission. And of course, there are cell phone transmitters all around.
It is even more than wildlife places. Okay, thank you very much, Professor Lai, for the answers.
Thank you very much for inviting me.
So I think we are done with the presentation. Thank you very much again for joining us tonight. Asuman Hanım, sizde mikrofon.
Teşekkür ederim. Thank you very much, Mr. Lai.
Yeah, thank you.
Teşekkürler Aydın Hocam, sunumunuz, yardımınız.
Thank you, Aydın, for ending the presentation. I'd like to invite Cemil Kocatepe. We will give an appreciation lecture. Professor Henry Lai, can you hear me, the interpreter? No, can you hear me?
We're gonna have a thank you speech from the chair of the chamber.
Oh, okay. Thank you.
Çok teşekkür ediyoruz Henry'ye. Gerçekten bizim için çok güzel bilgiler sundu. Biz gerçekten bu etkinliği çok sıkıştırılmış bir zamanda, çok büyük emekler harcayarak gerçekleştirdik. Ama sonuçta emeklerimizin karşılık bulduğunu gördük. Ondan sonra çok mutlu olduk. Bize bu etkinliğin yapılmasında katkı veren gerek yurt dışından, gerek yurt içinden bilim insanlarımıza, oturum başkanlarımıza, bildirileriyle katkı veren araştırmacılarımıza ve etkinliğimizi 2 gündür yoğun olarak izleyen tüm izleyenlerimize çok teşekkür ediyoruz. Etkinliğim süresindeki oturumları en kısa sürede Emanet'in web sitesinde düzenleyerek yayınlanır duruma getireceğiz. Burada Henry hocamızın da katkılarını bir an önce bekliyoruz, o bildirileri. Biz Türkçeleştirip yayınlayacağız. Ayrıca gene düzenleme kurulumuzu toplayaraktan bu etkinliğin sonuç bildirisini yayınlayacağız. O da en kısa zamanda olacak. Kamuoyuyla paylaşacağız bu sonuç bildirisini. Ayrıca bizim hazırladığımız Emanet web sitesine de gene elektromanyetik alanlar konusundaki yapılan çalışmaları, biz bugüne kadar 2011, 2013, 2015'i koyduk. Bu etkinliğin bildirilerini de buraya koyacağız. Tüm oturumları yayınlayacağız burada. Ama bundan sonraki diğer bilgileri de toplayaraktan bunun tüm insanların kafasındaki sorulara yanıt bulabilecekleri, bilgilenecekleri bir ortam yaratmak için çaba sarf ediyoruz. Ayrıca yine kamuya ulaşmasını sağlamak için yoğun bir çalışma ile yayını gerçekleştiren arkadaşlarımıza, şube çalışanlarımıza ve sekreteriyamızın Emanet 2021 etkinliğini düzenleyen 3 meslek odası olarak çok teşekkür ediyor. Herkese sağlık ve esenlikler diliyoruz. Herkese iyi akşamlar diliyoruz. Tekrar teşekkür ediyoruz hocalarımıza. Sağ olsunlar.
Biz teşekkür ederiz. You can sign off now, Professor Lai.
Okay.
Thank you again for the
Thank you. Yeah,
presentation.
bye-bye.
Thank you. Bye-bye.